this one if anybody needs it. Okay, so everybody see the slide?
Yes.
Okay. So we've talked about Ohm's law and what Mr. Ohms did. And he actually conducted a lot of experiments. And he took various materials and measured plotted points. He took measurements and he changed the voltage and measured the current through different materials and plotted it. And it turned out that they, except for measurement error, it basically plotted a straight line. So he determined that from experimentation that the resistance of the material was proportional to the ratio of the voltage and the current. So for a particular voltage, how should I say that? For a particular voltage at a given resistance, you're going to get a specific current. And that's going to vary in proportion to that constant resistance. Now, different materials all have different amounts of resistance, and we tend to use things like carbon or some metal films to make resistors when we manufacture them, and we can control basically the length of that carbon path and the thickness of it, which will determine the amount of resistance. The real definition is there. You don't have to actually remember that one, but that's how it's defined as the resistance between points, 2 points. When a constant potential of 1 volt is applied, it produces a current of 1 ampere. And then they go on to say, conductor not being the seat of any electromotive force. It means there's no other battery or any kind of external force in that circuit. And what we call Ohm's law, and I think I showed the formula before, is resistance is equal to the voltage divided by the current. And you'll see that formula a lot. And that's one of the, and there's a lot of questions dealing with that formula, which you'll see very shortly. But he did derive it by experimental means. There was no mathematical proof. And we honor him by using ohms as the unit of resistance. And like I said, sometimes you'll see the Greek symbol omega. Depends on who's writing it. This is kind of what one of his experiments would look like, although probably not exactly falling on the line. But if you plot voltage and resistance and current for a given resistance, it's going to follow this straight line, which is the classic first order formula, y equals mx plus b, where m is the slope of the line and b is the intercept for y. In this case, the intercept is at 0. So if we substitute ei and r in that basic formula, we get E is equal to, go ahead. We get E is equal to resistance times the current, plus the offset, which is 0, which is just another way of writing Ohm's law, and you'll need to be able to deal with it in all 3 forms of that equation. So for people that didn't have algebra, sometimes that's confusing on how you manipulate an equation. So the easy way is with this, we call it a pie chart. It's actually more of a pie chart when we talk about power. So if you draw a circle, divide it in half, and divide the bottom half into 2/4, and we label it E for voltage, I for current, R for resistance, that's the Ohm's law formula. So the way it works is you put your finger over whichever parameter you're trying to solve for. So if you wanted to find the voltage, in other words, you put your finger on the E, that leaves you with I times R. If you wanted to find current, that would leave you with E divided by R. If you wanted to find resistance, that would leave you with E divided by I. So it's a very simple way to remember it without having to do more algebra.
Go into the test,
You can draw that on the back of the answer sheet. If you have trouble remembering, I would advise you, the first thing you do is draw your circle. And there'll be another one coming up later. Same kind of thing with different letters, P, I, and E. There's just some examples of the three formulas. E is equal to I times R, I is equal to E divided by R, and R is equal to E divided by I, with some numbers and examples. So what formula is used to calculate voltage in a circuit?
It's going to be alpha.
Alpha.
Alpha sounds good. Let's see, B was amperes divided by ohms. I have no idea what that is. And you can't add different units. So these are totally different formulas. They're kind of meaningless. So these are one of those examples where there's two obviously wrong. So it had to be either A or B, alpha or Baker. What formula is used to calculate resistance in a circuit?
It's going to be Bravo.
Bravo. Once again, Charlie and Delta are way out in left field. What formula is used to calculate current in a circuit?
Bravo.
Right. Okay, I just did some example questions here before we do the ones in the pool. So what is the resistance of a circuit in which a current of 4 amperes flows when connected to 120 volts? So we use the formula resistance, what we're looking for is equal to E divided by I. When we plug in the numbers, 120 divided by 4, it would be 30 ohms. So what is the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 2 amperes? Same formula, plug in 12 and 2, we get 6 ohms. Same thing again with 3 amps and 12 volts. Divide 12 by 3, we got 4 ohms. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 60 ohms? So here we got to rearrange the formula. So it's I equal to E divided by R. Or if you do your little pie chart, put your finger in the right place. And we substitute the numbers, so we're 120 volts divided by 60 ohms, or 2 amperes. a little more than a 200-watt light bulb. What is the current through a 200 ohm resistor when connected across 200 volts? It'd be 200 divided by 200, or 1 amp. What's the current through a 24 ohm resistor when connected across 120 volts? 120 divided by 24, or 5. What's the voltage across a 10 ohm resistor if a current of a ½ ampere flows through it? So we're going to use E is equal to I times R. We multiply 0.5 amps times 10 ohms and get 5 volts. If the voltage across a 10 ohm resistor, or what is the voltage across 10 ohm resistor if a current of 1 amp flows through it? Whoops. I didn't change, I changed this, I didn't change that. It should be 1.5 amperes flows through it. So it's 1.5 times 10, or 15 volts. I have to fix that one. What is the voltage across a 50 ohm resistor if a current of 2 amps flows through it? So it's just 2 times 50, or 100 volts. So a real question. What is the resistance of a circuit in which a current of 3 amperes flows when connected to 90 volts? Beta works. There's different phonetic alphabets.
Okay, I keep saying beta.
I'm doing military. Yeah,
Bravo.
bravo.
Bravo. What is the resistance of a circuit for which the applied voltage is 12 volts and the current flow is 1.5 amperes? Need your calculator?
I'm
Is that
going
what you got?
with I'm going with Charlie.
Charlotte?
Charlie.
Oh.
12 divided by 1.5 goes 8 times.
The other way.
5 and 12.
Oh, gotcha, the voltage is 12, I had the opposite way.
Read the
Yeah, it's
question
kinda
carefully.
Yeah. It was
What
kinda
is the
confusing,
resistance of a
honestly, like-
circuit? Excuse me?
Oh no, I was saying like when you like take a look at when I took a look at the little like symbol that you put, the E and the bottom IR, I had to like put on the sides, like if it's on the sides, like you multiply it, like if it's going horizontal, and if it's going vertical, you divide it.
Yeah, if it's a vertical line, you multiply it. If it's horizontal line, you divide. Was that your question?
Yeah, I just made it easier for me to remember, like using the graph. I'm more like if I see a graph, like I can understand it a little bit more, even though like it's been a minute since I've done algebra. But when you said y equals mc, or I'm sorry, y equals mx plus b, I was like, yeah, I remember that.
Okay. Yeah, that formula turns up in a lot of places, actually.
Alpha.
I don't have the whole screen here, so I'm missing part of the formula.
Remember, resistance is voltage divided by current.
Yeah, that's where it gets screwed up on your time to divide, above is divide, right?
Mhm.
Yeah.
Right. Horizontal line is divide, vertical line is multiply. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? You tell me.
Okay, delta.
I'm not taking the test.
Delta.
You think it's delta? I think it's delta.
Which there, by.
I like the pie chart. It covered up the current and it's voltage divided by resistance.
Yeah.
120 divided by 80.
I think, yeah.
I like this pie chart.
That's
A lot of people do.
Mhm.
What is the current through a 100 ohm resistor when connected across 200 volts? Remember the example I did? It's almost the same thing. I only changed one number.
I'm gonna go with Charlie.
Yes.
What's a Charlie?
Charlie sounds good.
So.
Resistance is voltage divided by current. The basic Ohm's law formula. You know, the graph, voltage, current, straight line. What is the current through a 24 ohm resistor when connected across 240 volts? So we want current.
Charlie.
Mhm.
All right. What's the voltage across a 2 ohm resistor if a current of 0.5 amps flows through it? So now we want voltage. So your fingers over the E.
Current times resistance. So 1 volt.
It's. Yeah, it's most.
Mhm.
Bravo. Oh, Alpha.
Yeah.
Mhm.
0.5 times 2. Or 2 times 1 over 2. What is the voltage across a 10 ohm resistor if a current of 1 amp flows through it?
That's Bravo.
I was trying to remember.
Bravo.
Equation.
Very good.
That's shooting up on. Which way to go?
What is the voltage across a 10 ohm resistor if a current of 2 amperes flows through it?
The delta.
Delta. Okay, now you notice how many of those questions there were?
Yes.
Okay, odds are pretty good. You get one of those on the exam
Does it have a pie chart?
because they're all in the same group,
Okay.
but there's a lot of those compared to the others. So odds are good that you get one of those questions. Okay, we'll talk about series and parallel circuits. And we'll just use resistors for now because we've only learned about resistors. In a series circuit where you have 2 or more series components, and we're showing 2 resistors in series, and those little voltmeters and ammeters are just there to show you what the currents are and the voltages. The main thing that you need to remember, if it's a series circuit, the current is the same through all of the components in series, which it has to be. If you look at the circuit, the current I that's coming out of this source or battery, let's say, has to be equal to the same current going back into it. Therefore, the current has got to be the same through all the components. And if we try to calculate it, we know if you applied the Ohm's law, we can calculate the voltage drop across each of these two components. Okay. And they should add together to equal the source voltage. So if we have 10 volts here, E1 plus E2 should equal 10. And if we calculate each one based on the current measurement, we got a 5 ohm resistor with 1 amp flowing, which would be how many volts? 5 volts, right? And we have a 5 ohm resistor with 1 amp flowing. We have 5 volts. 5 and 5 is 10. They add up. Life is good. And Kirchhoff's law applies. So which type of circuit is DC current the same through all components? And notice they say DC current. This would not apply necessarily to alternating current, because if it was a non-resistive component, it's frequency dependent, so it's going to do strange things. Oh, I gotta turn my mouse off. So in series, the current is the same through all the components. If we have a parallel circuit where we have two or more components in parallel, all we know is that the voltage across each component is the same, but the currents may not be the same. Because if the resistances, in this case, 2.5 ohms and 5 ohms, we got 10 volts across 2.5, we're going to get 4 amps. We got 10 volts across 5, we're going to get 2 amps. So we have a total of 8 amps flowing here out of the battery, and did I say 6 amps? And 6 amps coming back, where it's divided up with 4 amps through this leg and 2 amps through that leg. But the voltage across each of those is going to be the same. So that's the basic difference between the series and parallel. Current's the same in series, the voltage is the same in parallel. In which type of circuit is the voltage the same across all components?
Bravo.
Yeah, bravo.
Bravo. Okay, so we learned our little pie chart or ear chart. That ohms were units of resistance, and series circuits, the same current flows through the all components, and parallel, the voltage is the same across all components. Anybody need to take